You might need a hook occasionally. I've had way too much coffee and only 4 hours of sleep. All right, fabulous. So let's go ahead, and this is a dual title presentation. The one on there is indeed putting a brain at the heart of DQMH, or also known as Secretary of the State versus Enemy of the State. I am Norm Kirchner. I work at NI. I used to be part of the LabVIEW and NI community for maybe like a decade before coming to joining NI, and I've had multiple roles in support, from systems engineer, application engineer, and now technical support engineer, the team of people that actually do the reactive calls when you get calls in.
I'm Darren Nattinger. I have worked at NI for almost 22 years now, I think. Thanks, Eric. The vast majority of that time was in LabVIEW R&D. So my passion while I was in LabVIEW R&D was making features for LabVIEW that delight LabVIEW users. So if you've used Quick Drop, that was me. If you've used the VI Analyzer Toolkit, that was me. But now I am for the past year and a half, I am also a technical support engineer, just like Norm, one of the senior people that's been moved into the group to help train the younger developers and build up the LabVIEW experience in the team.
Yep, absolutely. Yeah, technical support engineering, we want to be that the experts out in the field for NI delivering expertise out into the field for y'all. So this presentation, actually, go for it.
So we have two goals for you guys today. The first goal is that if you've ever spoken to Norm for more than 5 minutes, you've probably heard the thing that he complains about all the time in regards to queued message handlers and their inability to handle flow properly. So in this presentation, we're once again going to cover that topic and how it might affect your applications. Our other goal is that Norm has a special design for a queued message handler-like application called QMH Prime. And we, mostly Norm, are going to describe how that works. And even if you don't end up using it in your applications, our goal is to help you understand that design.
And the third one that wasn't noted before is that basically if all else fails, you will be entertained. So that indeed will be part of this. So, all right, so indeed, we covered goals. We're going to cover this definition of state, right? That's a big part of this presentation. We're going to go through the problem associated with it. Darren mentioned earlier, like my solution. Also, Darren has counterpoints to that. So Darren is a DQMH, Delacorte queued message handler guru in a variety of different ways and means. And so basically bringing his expertise that he just naturally pukes out whenever he works on a project so that you can enjoy it and do the same type of development that he does. And then my counterpoint to his, and then of course the wrap up for that.
In other words, we're going to be arguing for the next 45 minutes.
Yep. Absorb, be sponges. All right, so indeed, before we get started, let's talk about some nomenclature and some natonyms. All right, so we will be using words that could be clear as chocolate milk, so we're going to try to clarify them here. I added this one in here. So when I talk about the word state, I kind of interpose this idea of mode of a program interchangeably. You'll see what this effectively means later. State is not necessarily equivalent to state data. There are different people and different paradigms of programming that might refute that, but in general for this presentation, those two things are different. Get out of there. Actions equals message equals sort of requests. If you're a DQMH user, you probably the requests, right? That's the thing that's normally, there's queued message handlers, right? So there has to be messages. And I will always use the phrase actions associated with that. So these will all be interposed. And then actions and messages are not equivalent to state. So we'll talk about what that means in a minute. And then do's are actions and messages. And then I think this is the last one, is you will hear me use the word brains of a program. That effectively is kind of the state machine of the program. So, all right. And this was you or me?
This was you.
This was me. Okay, cool. All right. So for those of you, so does anybody in the room, be bold and about this, does anybody not understand or know what a queued message handler is? Anybody? Terrific. Okay, so we're just going to cover the list here. Everybody knows what it is, but there's the NI queued message handler, ships with LabVIEW. There's the Delacorte one. Active Framework is technically a queued message handler. There's TLB, TLB Prime, TLB 2.0, and TLB Full Tilde, which are all my brain children that are also queued message handlers, and then the JKI state machine and all these other things. But basically, it comes down to this. DQ, and then do a thing. Action, message, whatever else, right? That's really the core of a queued message handler along the way, right?
All right, so I just want to say a couple things here on, what templates we choose to develop with. This is not going to be a my framework is better than your framework presentation, despite the fact that I said earlier that Norm and I are going to be arguing. We're not here to say that somebody's framework sucks and someone else's doesn't. Everybody in this room has likely been successful with a framework. Maybe it's DQMH, maybe it's Active Framework, maybe it's something else. But lots of people have been successful and made lots of money with lots of different LabVIEW frameworks, right? So like DQMH, right? Like it comes naturally to Fabiola and me and Matthias and Olivier. That's okay. Active Framework comes naturally to Steven and Alan and Casey and Derek, and that's okay. TLB Prime comes naturally to Norm, and that's okay.
There's a guy in South Korea that really likes it.
Oh, and apparently some guy in South Korea. So all I'm saying here is that we've all been successful with these frameworks. There are differences between them. There are different ways we think about programming when we're using them, and that's okay.
Yeah. Which is very nice of Darren. He had to reel me in on that one. So, all right. So what is this top-level baseline thing? TLB acronym. It's something I came up with years ago. But basically, it's a queued message handler that takes into consideration some of the common things that go wrong when you're just starting from a blank block diagram. This was birthed back in around the 2005 timeframe, so it predates DQMH, it predates the NI1, predates a lot of the community-driven queued message handlers. But basically, it was, hey, if I'm going to make an application and I want a queued message handler, what are some of the common things that I want to have happen? Let's just make that part of the template. Like when I build it into an executable, I don't want to see the run arrow. When I go ahead and I hit the X in the top right corner, I want to gracefully close down my program. I don't want a stop button. That stuff's just kind of cooked into the template by default. Once again, whoop, hold on. Good. All right. So the additional explicit, but the thing is of the prime directive in this case, is it's a queued message handler with a state machine attached to it as well. And then we're going to really get into the guts of that one. But basically that state machine, the brains, declares the flow of the program. And of course, and then, I already mentioned this. And this is Darren's definition of, Darren had told me while we were reviewing for this presentation, he said, Norm, I think what I could boil your thing down to is a sophisticated, stateful trigger response mechanism with a shitload of white space. So we'll talk about what that is in a minute. You'll see. Demo? No demo?
Demo comes later.
Demo comes later. Okay. All
right. DQMH. How many of you have written at least one DQMH module? Excellent. So DQMH is an event-based framework for developing LabVIEW applications, whereas some of the things like Active Framework use a queue under the hood to send messages between modules. DQMH uses events. It's a free download on the NI Tools Network. It is not made by NI. It's originally made by Delacorp, but is now maintained by a nonprofit called the DQMH Consortium. Fabiola de la Cueva, she's been mentioned already this morning. She is the chief architect of DQMH. And if you ask her point blank what the benefit of DQMH is, she's not going to say it's the framework itself. She's going to say it's the productivity tools, the tools built into DQMH to create new events, to create modules, et cetera. That's its main calling card for helping you be a more effective LabVIEW programmer. The way DQMH works is you've got different modules running asynchronously. Calling code will send a request to a DQMH module, which is an event under the hood. It can optionally send some information back, et cetera. And if a DQMH module needs to communicate to the outside world, that's also done with events, with something called a broadcast event, which anybody can register for and get information from that module. Those of you who have developed with DQMH know what I'm talking about here. And as I mentioned before, unlike some other frameworks that use queues or other mechanisms to pass data between modules, DQMH uses user events. Now, the thing is that the outside world communicates to and from a DQMH module with events, but within a module itself, the local communication done within the module, that's done with a queued message handler, hence the name DQMH. And since Norm had to say my quote about TLB Prime, I have to say Norm's quote about DQMH, which is, it is a ridiculously tool-rich QMH that fails to solve the big issue and thinks you'll fit code into 550 by 380 pixels.
Who calls that small? So, all right.
All right, so what is state? Well, let me answer that with an analogy. The iPhone is not a phone. I'm sorry, it's not. It's an internet device, which very occasionally you might use as a phone. All right? The simple state machine that ships with LabVIEW is not a state machine. We use that terminology. Some of you guys know my colleague at NI, Christian Lowe. He hates the fact that we called this thing a simple state machine because it's not a state machine. That enum is not a state. That enum is a command. or a message. So instead of calling it a simple state machine, we might call it a single message handler because it handles a single message at a time. But if we move over to QMHs, well, some people will refer to the different frames of the message handling loop in a QMH as the states. Again, that's not a state. You're handling a message. You are responding to some message that's coming in. This is also not a state machine. Norm, what's a state machine?
So, well, in particular, I just wanted to, before we get into what the specific is, it is not a bunch of doo-doo, right? Everybody's state machine that does even the simple state machine and so on, what you're doing is basically you're making each one of these states a do kind of thing. And so that's kind of very similar to that first diagram of the simple state machine is not a state machine. It's a bunch of doo-doo. So then that's what you've got all over your program. So don't put doo-doo on your program. So what is a better definition of state? And this kind of falls into the nomenclature end of it as well. If you went to, some computer scientists, they might refute some of this stuff. But the way it makes good sense to me, once again, going back to Darren's point of frameworks that make sense to you and you can be successful. This concept makes sense to me. A discrete mode of a given module which classifies specific behavior to stimulus and state data. So let's talk about what that means. So let's talk about the state of being. My program is monitoring. It's recording. It is connecting. It is in the process of doing a thing. It's not a specific action. It's a state of being. And very often you'll see these ings tailing off of what the states are, or the mode of the program. So usually you can tell the mode of a program or the state of a program by, hey, there's different visual indications. I've got this disabled. I've gone from this tab and I forced this tab. I don't need this right now.
You lost your mic.
I measure my coffee consumption in decibels. So yes, there's the visual indicators on your program itself. So of course, if I've disabled things, and you're going to see an example of this, the CLD ATM example. And basically we're going to enable controls, we're going to disable controls. Certain things are going to do different things. The program is operating differently, different modes. And the way I like to think about it is that also, if you can think about your program and you can functionally contain those behaviors, you can think about each one of those states as being a discrete brain that has authority over the rest of the program, that takes in input and says what should happen next. That makes good sense to me. And so as an example, you could say that I am idling, I am connected, I am monitoring, I am logging, I'm shutting down, handling error. These are all states of a program. That's how I would break down a potential program. And this is just basically a nice visual description of how a program is supposed to run. Those individual brains, I should have done like an overlay of a brain on each one of those things, right? But it's like, if I am indeed recording, I'm going to respond differently to if somebody says shut the program down than if I'm at idle, right? I should do different things along the way. And so this leads us into the problem statement. I think it stays over here, right?
You should do this one.
All right, oh yeah. All right, so what is the big problem in this one? I'll try not to harp on it too long. You can go watch my other presentations online from 2017 if you want. But the problems with traditional QMH is that all but the most simplistic, and that's kind of a key thing, but all but the most simplistic QMH modules will suffer bugs, have difficulty debugging, and implement poor fixes or workarounds due to no stateful and explicit flow control, right? Let's talk about some code smells of what these things will look like and that you may have seen yourself. You may have a problem if. So your flow stinks if happy dancing on a button causes problems, right? If all of a sudden Windows decides to start connecting to a network thing, right? And somebody's like, it's not responding. I'm going to click 20 times trying to get this thing. And all of a sudden the program goes into a irrational and illogical flow because there's 20 button clicks before you had a chance to disable the button. There you go. You have a flow problem. Understanding the program operation is not obvious from the code, right? If you have to go into every single different message handling or every single different actor and all the things to figure out how the bigger program's supposed to run if the code doesn't describe itself, I say, at least, that you have a flow problem. The code controlling the flow is mushed together with the do code, and we're going to see an example of that in a second. It's like, hey, do this message. I'm going to indeed open a network connection. Cool. Open the network connection, but don't say what that do shouldn't say what the program does next. And then, or here's a good one that Darren agrees with. Darren agrees with me on.
100%.
If you use preview queue or flush queue, you've got huge problems. You've got bugs waiting. Thank you. More applause, please, on that one, right? You have a flow problem, right? Or maybe the big hallmark or the capstone of this is if you spent no intentional time thinking about how your program's supposed to flow or respond to different stimulus, you're guaranteed to have stinky flow. Okay, so this is a great example it's a pretty reasonable example. This is for the ATM. This is a colleague of ours that created the ATM, did a queued message handler, the LabVIEW-based one, the stock one, and this was his message for check account. Anybody want to take a stab at what they think is wrong with this? And basically, I can kind of hand wavy, getting balance, doing some math, have sufficient funds is true, then do other things. What potentially is going to go wrong with this? Anybody want to take a stab? Can you see it in the back? Iffy. All right, Steven? Uh-oh. It's not active framework. Yes, we know. Sorry.
You're going to be updating the account while the next check account message comes in.
Yep, so,
While you are off trying to update your account balances and everything in this asynchronous process, check account is now free to handle the next message, which may be doing the next check account operation.
yep, injection of messages in between your intended flow of messages in the system. Huge potential problem there. That's just one of the problems. Anything else? Anybody else jump out at anything? So for the sake of time, what about when somebody wants to do check account again and it has nothing to do with withdrawal complete? Nothing to do with withdrawals. Basically, his program works. He could have passed the CLD with his program. But what happens when and this is Darren's, you're going to see a slide on what if in a second, right? But what if somebody wanted to use this message, check account, again in the future? Well, then all of a sudden the combinatorial logic that you've got to cram into 500 by 380 pixels now has to fit within this other all code, and it starts to grow and bloat and be very weird, and all of a sudden all that logic of how the program's supposed to run is now mushed into something that was just supposed to check the account. I don't know, that's like I said, that screams problem to me.
Go back to that slide. I just want to say one thing. I agree with most of what Norm said. I agree that this pattern right here is problematic. I do want to point out, though, that the use of the NIQMH does not mean you are guaranteed to have these problems.
Yes.
You can write an application with and this is the NIQMH, you can tell because these are the VIs that come with it. You can write an application with the NIQMH and be successful and not have these type of problems. You have to know to look out for that, and you have to know to separate the responsibility of your different messages accordingly. So I just want to point out that it's not you're not guaranteed to have these problems, but like Norm says,
You're more likely to walk into them unless you're intentional about it,
Yep.
and that's the big twist. All right, so another big kind of capstone statement. Performing, a lot of capstones on this thing, right? Performing a specific action and making choices of what to do next are categorically different. They're two separate things. I'm going to do a thing, and this is what I should do, right? Those are very, very different. And if you try to follow any kind of programming principles, be it S'mores, which is one that I'm a prophet of, or the solid one, which is Dimitri, unfortunately he's not here, but indeed, these principles, single responsibility and modularity or functional containment, you have basically mushed two things together, and you're going to suffer the repercussions of mushing two things together that don't necessarily belong together. All right, we're a little over. All right, so, and so I think this is the last part. Okay, so this is great. Yeah. So another way to think, because basically this presentation isn't going to be a bunch of code. It's trying to help you learn how to think so your programs can be more robust. So for me, once again, the paradigm that makes real good sense to me is when I think about a program, I think in terms of the modes of the program, and the state nomenclature is a natural, self-declarative method of ways of defining the flow of a program. So when I want to talk about, I'm going to describe my code to Darren. I don't talk to him about all the actions. Oh, here's this action and this action and this action, or message, right? I'm talking to him about how the program should flow so he can think of, well, I need to modify it or fix something. What section do I need to focus in on? So let's take an example of our own lives. Once again, helping you learn how to think. You behave differently to different requests based on state and state data in your own life, right? We all do. Example, request, change my poopy pants. I'm a father of twins, so if I'm in my state of daddying, what is my response? What are my actions that I should do after? Well, I should break out the wipes and the nose clip. So that's it. However, if my state is bachelor partying, then indeed the response is to push my friend out of a car near a gas station, right? Different states, same stimulus coming in, I'm going to respond differently to those things. There's less laughter to that one than I figured. Is the picture not clear or something? I don't know. It's okay, this is semi-professional here, right? All right, so
what it boils down to is how much do you care about the flow in your program and the state that it's in? All right? TLB prime, which you will see a demo of very shortly, it elevates the state and the flow of the program to be first-class citizens in the application. That is what you're thinking about when you're writing code with TLB prime. How do I flow from one state to another? When this message comes in, how do I respond based on what state I'm in? That is what you're thinking about the whole time you're developing with TLB prime. Now, I'm a DQMH guy. I don't actually think that much about state and flow. To be completely honest, I think about the public API for my DQMH module. Those of you in here who've written DQMH modules before, you know what I'm talking about. I'm thinking about how external code is going to interact with my module. That is the first-class citizen in terms of my thought process when I'm developing with DQMH. And like I said in my disclaimer slide early, that's okay. Norm's thinking about state and flow when he's writing TLB prime. I'm thinking about public API. Like it or not, the framework that you choose guides your thought process when designing the application that you're working on.
and also I would say the kind of the contrapositive of that one is how your brain naturally works will indeed guide you towards a specific kind of implementation along the way. That's why I made the prime part of TLB prime, because I was like, my brain just kept wanting to have a brain in my program, so it kind of grew out of that one. Okay, so onto some code, onto some solutions. I think we're actually okay for time.
We are.
All right, terrific. Now this is probably where it's going to go off the rails because it's just going to be me talking for a minute. So let's talk about this TL. So does everybody here, does anybody not know about the ATM sample project for the CLD exam? It's okay if you don't. It only takes about 2 minutes to go through it. Sweet, 2 minutes. Okay, so I will do it for him and for the three other people that didn't raise their hands.
It's an automated teller machine.
Yep.
With buttons to withdraw money and
but
add money.
Basically, they give you buttons. Yeah, so basically, it's like, hey, they're going to give you these menus that they click, and it's all the basic core functionality that ends up happening along the way of this individual program. There's a simulator for if you insert or take the card out, and basically virtualizing a keypad with an enter key on it, right? And it's supposed to run and respond and timeout and all the natural stuff that you might expect from an ATM. It's pretty basic, but I'd say it is a pretty good CLD example. So for me, trying to decompose this situation, the very first thing I did is I busted out my whiteboard, and I'm like, okay, what would be the states of an ATM? And so and I'm going to go ahead and do my ubiquitous zooming here into the system. There we go. So first up on the list ends up being the top level program, right? Top level baseline, that's the way I think, right? So, okay, there is an idle state or idling, right? There's a card inserted, a validating state. I'm at menu home. I'm withdrawing, I'm depositing. So these are the ways, so basically I know my program's gonna respond differently to somebody entering a value in for withdrawing as opposed to entering a value in for depositing. However, this is the triggers of the system. I didn't put that triggers are the outside stimulus, right? They're the functional equivalents of events or requests. Requests, yeah, yes. The functional equivalent of requests in DQMH. But each one of these things, user card inserted, user data entered as a trigger. So when somebody hits the big E button on that front panel, it fires this trigger. And whichever thing I'm in, it's going to behave differently. Like if the card's inserted, somebody hits the big E, it's going to actually go to the validating state to validate what the person did. It's going to do whatever it needs to do. Like I'm invalidating, and then it's going to, what do I need to do? Well, I need to do some actions in order to validate, and then eventually I'm going to go to home. But basically that same trigger, user data entered, is going to cause different things for the withdrawing. Kind of makes sense on this one, hopefully, a little bit natural. And then the other part of it, but in the system, much like DQMH, I'm not of the mindset that everything has to be in one top-level VI. Because that's the way we all developed for a while. That's just the community in general, just monolithic VI, do all the things, right? And over time, the community, I think it was, I forget who really led the charge. I think Actor Framework really led the charge. A lot of people liked the idea, but they're like, but I don't like AF. And so people started making more actor-oriented designs to facilitate that same desire, but kind of staying with what they're familiar with, the same queued message handler. And so for me, for TLB Prime, the same concept exists, and so I made an account manager module. And it has its own states. It doesn't make a difference how simple something is or how complex something is. Everything should have a brain associated with it, even if it's just 3 states: idle, database connected, and account locked. Right? If somebody, and these are the triggers. So if somebody says withdraw, but I'm only connected to the database and don't have an account locked, I'm going to ignore it. I just let that request effectively fall on the floor. Or I have the authority as a programmer to indeed respond to it or handle it, but it's intentional. It is part of that flow, like I said. Yeah, I think it's probably good for this one, right? Yeah. Cool.
Show us some code, man.
Show some code. All right, that's the last, yeah, because that's the. All right, so before I get into the specific code, I want to show, here we go. Go straight to the code or a simplified version. I'm going to do this, because much like most frameworks, once you actually look at the other L code, you end up looking at a lot of the other things going on at the same time. So we'll get to the ATM in just a brief moment. But before I actually show that one, I want to show a very simple implementation of what effectively would be, or basically is your traditional queued message handler.
He promised me he wasn't going to do this, but he's doing it
No,
anyway.
I'm not going to run I'm not going to run. I'm just showing the code.
Okay.
It's just for illustrative purposes. What's that? We work through it, So your traditional queued message handler, this should look familiar to almost anybody, right? Event-driven queued message handler, to be more explicit, right? Events, it in-queues things up top, and it does stuff in the bottom. But one categorical difference that makes this prime directive possible is that there are 2 queues in this. In this case, I just have this blue wire, if you can see it, and then there's your traditional string-driven queue that's down here. And actually, that shouldn't even be going through there. But in general, everything in the program, the only thing in the program that should have authority to put things on this string-based queue down here should be the brains of the program. Because the brains of the program control the muscles, right? It kind of harkens to the MVC model view controller paradigm a little bit, for those of you who know what that is. But in general, everything in the program, whether it's an individual action or an event that happens in the program, it should just be sending information into the brain. And so in this case, I can talk to you about how my program runs, and this is just basically something that should just click through action 1, action 2, action 3, action 4, action 5. When you hit start and when you hit stop, it should save data. Nothing grandiose. It's just an extremely simplistic concept. But I can describe the flow of my program not with a flow chart, and this is a big thing, right? How many people have actually taken out time on line plotters to actually do a plot of how your program should actually flow? And it takes like 4 feet by 7 feet to actually describe the flow of your program, because you're using, was it a flow diagram, or what's the? No, not a sequence diagram. No, in this case where it's like, is this true? Yes or no? Go over here, and that's not a sequence diagram. That's
Like
a flow chart. Yes, indeed. Thank you. That was it. So indeed, a flow chart. So I can describe my program through this state diagram. It goes into startup. It goes into idle. These are the triggers that are of the system for this very simple example. When I hit start and I'm in idling, I go into processing, and processing do what it does, and when processing is complete, it goes back to idle along the way. And so I have a nice diagram to refer to the flow of the program, and then I have a case structure. All right, this is going to be a little bit harder for me. The live zoom isn't flying the way that it should. That's not a LabVIEW feature, don't worry. Don't worry. But indeed, so I have this outer structure that's right here. You can see the conditional. It has the very specific states of the program, right? And in this case, I am in the processing state. Now, if I'm in the processing state and somebody in-queues the trigger to start sequence, what am I going to do? I'm going to put in all the actions associated with handling that effective request. And then I'm going to go and burn through all these actions, and once all these actions are complete, then I'm going to come back to the brain, and I'm going to say, okay, I'm back in the brain, my actions are complete, what do I do next? So the TLB example of that one, or sorry, the ATM example of that, come Don't slow me down, oh, having such a good time. There we go. Cool. Let's see. So one thing's, right, I've got my top level ATM Prime, and I've got my account manager in the system as it exists right now. If I go into my ATM Prime, you'll see there's a lot of individual white space, which is okay. And it's actually helpful, because then you don't have to resize the diagram. And I can walk through and justify each one of these things and the colors and stuff like that. But once again, here are all my actions of the system that you can see. You know, there's a little bit of
Nomenclature.
Semantics that we're using here. Nattinger. Anyways, that, hey, these are all the things. I can load soft button menu, validate account, load account information, remove funds, add funds, and basically I know I can look at what my program does for those very specific actions of the system. But if I go to the brain of the program, I can now look, hey, there are the states of my program. Idle, card inserted, validating, menu home, deposit, withdraw. The same things that you actually saw in the state diagram itself. And I can actually talk someone, I can try to talk y'all through how this program flows, basically just by walking through a single diagram. No extra windows, no extra things. It's just all on one diagram describing the flow of this nugget of an overall program. So indeed, the program is in startup. Once the program is in startup, what does it do? Well, here are the very first things. It's a load application base path, initialize front panel values, boot the account manager. You know, these are the actions that happen during startup. And when that's completed, guess what state it goes to? Well, I have a very specific declaration. It goes to the idle state once it is done doing those actions, because that's what the startup state does. It do these things, go to another state. So once I'm in the idle state of the program, if nothing happens, well, display some messages and go ahead and stay inside of basically this blue wire that you see down here. Hopefully that's clear enough. That's just a basic declaration of, it says new destination. Y'all can't see that, I could zoom in, but it's basically saying, hey, what's the next state I should go to when I'm done doing any of the actions that are in the system. But if while in idle, somebody goes ahead and inserts a card, well, guess what I'm going to do when somebody inserts a card and I'm in the idle state? Anyone want to take a stab at that? There you go to user inserted card. Yes, absolutely. That's the next state of the system. So there you go, user inserted card. You know, normally I might do some extra things here. I might, enable a lock on the card so they can't pull it out, whatever. But in general, I'm describing what happens next. I go to the card inserted state of the program. Okay, well, what happens next in the normal flow, the happy flow as somebody called it once? All right, well, if the card's inserted and nothing happens, then pretty much, well, don't do anything. Just sit there. Oh, okay, that's fine. That makes sense. Somebody can just sit there with their card inserted. But what ends up happening when somebody actually does the user entered data or user removed card? Well, I'm going to respond to that in very specific ways. Hopefully you're following along, and I'll go ahead and probably tail off here. But let's see. Let's see if I can get to something more interesting. There you go. So this is a pretty reasonable one of, hey, user has asked for fast cash, right? There's a button on there, fast cash. It should kind of auto withdraw $50 from the system. And so what do? Well, this whole brain part of the program, it's not just about, you're not just looking at triggers and saying what happens next. You have triggers and state data, and with the combination of data plus stimulus, once again, my example from my life, I'll leave the details of that one out, then you declare what you do next. So the way I'd look through this is I'm at the menu home state, which is the topmost there. Then I've received the fast cache trigger. Then I basically look at, hey, what's my station configuration for the fast cache amount? What's the current balance on there? Hey, if there's enough money in the account, then go ahead and do the withdrawal. Go ahead and remove the funds and, let's see, what's that? Yeah, and then just go back to menu home. And so this is just like I said, a very light top-level walkthrough of, just that individual nugget. And if I go to the account manager, the diagram looks the same just like DQMH, you kind of walk on individual diagrams. But there's those states that we had, idle, connected, account lock along the way. And really, if somebody's in the database connected, right, so I've gone through and I've done, let's see. Yeah, this is maybe a good example right here, right? I'm in the idle, I have connect account database. And what happens? If somebody says connect the database, what do? Well, I open the database and then I load the accounts. I don't know what's going to happen with that. And in fact, I don't even need to actually put any code inside of these methods or these actions or these messages to actually have my program run and actually have a logical flow. And that's a huge thing for me. I love to actually test my program before it does anything to make sure the flow goes in the right way. And then once the flow's knocked out, okay, now let's start putting meat inside of each one of these messages or these actions to be handled. It makes, once again, my brain a lot of sense because now I'm focusing on the flow. This is what Darren was saying. I created this module last night in a fervor to try to finish this thing off, just-in-time engineering. And yeah, it just worked really well. I got the flow, did the things. Okay, now let's actually go ahead and do file, open, create. Let's read from the files and do all the hoo-ha associated with the account-based stuff. So, yep, for the sake of time, we'll go ahead and, but I talk fast, lots of hand motions, lots of zooming. Is that query for question? Just go forward. I defer to him on this kind of stuff.
Does anybody want to ask anything about what you just saw?
Yeah. How many people are completely confused? Let's just go there, because that just means I screwed up. I'm not going to go, don't worry, I'm not going to try to clarify at this point. I've lost my opportunity, right? Is anybody completely confused? Like just dead? It's okay if you are. Okay, thank you for being honest. Oh. Okay. Wait, I'll run it back, come on. I'll run it back. No, I got the energy, come on. God.
Jason Dahl, Sandy, Utah. So what would you say to, so everybody in this room is advanced, but our LabVIEW education begins with the classic LabVIEW state machine. So I'd like to know how we might correct our concept with that level to introduce new users. Second reflection, and correct me if I'm wrong, but it seems like you've nested a classic LabVIEW state machine inside another state machine.
No.
Or cube message handler, but you have separated the actions. I get your filtering example with the poopy diaper, etc., and that makes sense, but is that an accurate understanding?
So Nancy's in the back. She's waving her hands furiously.
Yeah, so I have an answer. I can learn how to turn on the microphone, at least on the education side. Good to see you. I'm very closely working with Megan Carey, who is helping design a lot of our future courses. And we're starting to do courses that are more modular. So in the future, when you sit for a LabVIEW and test stand course, it's going to be 8 hours every day, or 8 hours every week. So 8 hours one day, 8 hours the next. And we're in the middle of designing that course right now. So I'm going to make sure I talk to you guys, and we're going to make sure that anything that is historical that needs to be ripped out will be ripped out.
So for the sake of...
Real quick, I do think that the simple state machine is a state machine in much the same way that a lever is a machine. It is the degenerate case, and there is value in teaching that to the new users, because you couldn't follow this diagram without knowing the fundamental pieces of while loop plus enum plus case structure and shift register. We have to get that, so that is a part of teaching it, and it is important that it is in Core 2. I literally just finished a rewrite of Core 2 a couple weeks ago. It's important that it is in there, and we build from that. Now, how we do the next layer up, that's what this conversation is about.
Terrific. So I want to give Darren the stage for this one, but to answer your question, yes, it is a state machine embedded inside of a queued message handler. The state machine is the brain. The queued message handler still is the queued message or action handler in the system. So we can talk more afterwards after that. So
just for timing, we got 20 minutes, so I don't know how many more slides you guys have.
yep, we're going there.
All right, so I also solved the ATM, but I used a DQMH. Norm asked me to go in and take the problem statement from the ATM and implement it with a DQMH, so I did. But before I talk about that, real quick, I want to talk about Chewbacca. So this is a picture of my son Sage's 5th birthday party. It was he's 14 now, so this was a while back. This was a Star Wars party. As you can see by the fact that the piñata is Darth Vader's head and the stick is a lightsaber. And the Chewbacca is Norm, actually. Norm went out and rented a Chewbacca costume. I don't know how much he paid for it. He's probably still paying it off at this point. But he showed up, surprised my son by being dressed up as Chewbacca. Norm is a very close friend of mine. So we've been friends for over 10 years now. And don't take the fact that I'm going to try to tear down everything he just said as an indication that I don't like him, okay? So this is my favorite meme of all time. I quote it very, very often. I showed Norm my DQMH implementation with the ATM, and he's like, well, what if this happens, and what if this happens, and what if that happens? I'm like, dude, it's not going to happen. There's a case to be made for over-engineering versus under-engineering, and those terms are overloaded, and they have a lot of pejorative associated with them, but you're going to see my implementation of the ATM is quite a bit simpler than what Norm did. And again, I think that's okay. So I created 3 DQMH modules to solve the ATM. And that, coming back to the over-engineering versus under-engineering, if I under-engineered this thing, it'd be all in one gigantic loop, like Norm was talking about, right? Like I put some thought into how this application was designed. Came up with 3 modules. Turns out there's only one piece of state data for the entire thing, and it's one enum, and it's in the main ATM module, and that's whether or not I'm waiting for the user to do something. That's literally the only piece of state that my entire application has. And if you design DQMH with a focus on what are my modules going to be, which is the first thing I thought of, Norm's first thought was, what's the brain of my TLB prime going to be doing whenever triggers come in? My first thought was, what are my modules going to be? And those are my modules, the ATM, the timer, the account manager. And when you have very simple modules, and this goes way back to a point Norm made early on in his slides, you may not remember, but he had a point where he said, all but the simplest of QMHs is what he said. These are pretty freaking simple QMHs right here. And you can see that the timer module, no state. Account manager module, no state. Main module, I got to know if I'm waiting on something. Just as a quick aside, that diagram was generated for me by a tool called Antidoc, which is a documentation tool that's mainly used for DQMH, but can also be used for other applications as well. It's an extremely useful documentation tool. It's made by Olivier Jourdan, who works at Wova Lab. If you search on VIPM, it's just called Antidoc. You can download it. It's a free download. And it generates documentation for your entire project. Again, mainly geared toward DQMH projects, but that diagram was generated for me automatically, which is was really handy. You know, Norm had to make his diagrams. I didn't have to make my diagram. It came for free. So I need to get there. So I'm going to show you guys my code. I'm not going to spend nearly as long as Norm did. Let's see. So there's my modules. Let me go in and show the main module. Oh, first, what's that?
ATM, timer, and then account managers, 3 different libraries.
So the timer module is the one that keeps track of whether or not something has happened within 10 seconds. Otherwise, it logs you out of the ATM. There's something called a helper loop in DQMH. That's what that loop is on the bottom. The rest of everything in the timer module is pretty much boilerplate. I implemented a helper loop to keep track of whether 10 seconds has passed or not. And the account manager module is also very simple. Control E doesn't work. Oh, did you make it function E? Function E. There we go. The account manager as well, very simple. Keeps track of things like the current account balance, deposit, withdrawal. That's all stuff that's done in the account manager. One of the great things about DQMH, if you haven't used it before, is for free. Remember we talked about those productivity tools that it provides? For free, I get these tester VIs. So I can test my timer module independent of running the entire application, just to make sure it's doing its thing correctly. I'm gonna have to get used to pressing the right key. The account manager module, make sure that it's opening the file correctly, withdrawing and depositing correctly without having to run the entire application. This is stuff I get for free in DQMH. And then the main module, really all I had to do in terms of making sure things work okay with the other modules is in DQMH, you're going to see this pattern a lot over here. These are the dependent modules. So if you think of like an actor framework, you've got your actor tree. This is kind of a similar concept in DQM. Why are you doing this? So timer and account are the ones that are sort of called by this module. So I need to start them up and make sure their events get synchronized. Norm was actually telling me about a bug in his TLB prime implementation last night where a module was trying to do something when another module hadn't started yet.
And it was very easy to solve.
And it was not ever a problem for me because I did this pattern right here. So the only other thing I want to mention, since Norm took so much time on his demo, is,
15 minutes.
you know, I told you, over 10 years. Am I using the right mouse? Did you take the mouse?
Possibly. Oh, it's up top. Get rid of that.
I don't know what mouse that is.
Yeah, make fun of me. Here, go here. Keep the mouse.
All right, so Norm's always complaining about how everything in my DQMH code is crammed in, but I figured to make Norm happy, all I really need to do is just this, and now Norm is going to be extremely happy with the way my code looks. Is that right? This looks just like his demo, right? All right. Problem solved.
Let's check out the other cases after that. All right. So, in the sake of time, we're going to go actually, and the lack of code that actually exists for this one, I want to talk about DQMH and possibly changes in the future. We're going to have to basically do this. So what is the desire for the DQMH, right? I want to continue to leverage the tools to create and manage the DQMH stuff, right? Such worth going on right now. There's tons of, like, shitload of, truckload of features that it absolutely has on there, right? But there's more to Prime, right? Anybody? TLB Prime? Oh, man, I just don't have it like you. Anyways, but there's this other part of it of trying to figure out how to not break all the tools while trying to add a brain into the system. And so I was intending to actually have this rocking and rolling for this presentation. Mea culpa, I have failed on that one for a variety of different reasons. But we have some examples that other people in the community that do use the prime concept, like Mark Bala up front here, who's a longtime friend of mine as well, who also thinks in this manner, so stuff just makes sense to him in this, that he actually found a way to actually continue to leverage the tools while breaking the link between the request and the do. Because by default in DQMH, you make a new request, it instantly makes a do for you, right? Make an event case to handle that event, and then instantly fire the do in your main message handler down there. Which, like I said, for the plebeians among us who don't necessarily think as naturally as Darren does in like ultra simple QMHs, that leads to this, it kind of precipitates possibly having these flow problems along the way. But the idea is that we want to break that linkage ship. We want to have the request event still come in. We still want to enqueue a request, but we don't want it to be digested by that main message handling loop as it does right now. We want that to go to something else. We want that to go to come on, there's somebody. We want it to go to the brain, yes! I'm getting them there. This is fantastic. So indeed, it will digest that, and then it will queue up the actions from there. And so, yeah, I really got turned on my head last night because Darren was talking about this in terms of, helper loops. I'm not a DQMH person, and so not necessarily that I, vehemently oppose it or anything else like that, but once again, my brain works in certain ways. So, hey, there's these helper loops. Can I leverage a helper loop to actually go ahead and be the brain of the program? I have not figured that part of it out yet. But the reality is why I think this is so important, and the whole reason I made TLB Prime the way that I did to the question that happened in the back of like, wait a minute, is it actually just a state machine with the queued message handler? And it comes back to this idea of maintaining the queued message handler familiarity. And so if you're willing to work with me and Mark, and I'm going to show his example possibly, I got 10 more minutes, right, Tim? 10. Sweet. I think
I
we're
still
okay.
have stuff too.
You still have, okay. So we're gonna, okay. So, what's that? Okay, 8. So in general, but the idea with, like I said, with TLB Prime is I had a queued message handler. An actor framework came out. And it requires you as a person to completely rejigger your brain in a lot of different ways, and all the familiarity that you might be used to of just having this nice stacked structure to go brrrr and look at what your program's doing goes out the window, right? You've got all the different do's, and it's harder to get to that information. Like I said, I am friends with Steven. We've all been friends with for a long time.
Deliberately harder.
Very
clear.
So yes, indeed, deliberately harder for a variety of good reasons. Those reasons, I wanted to be that bridge builder between better programming and the queued message handler that the industry was starting to adopt in heart, actually back in 2005 and before, right? It's been an evolution even amongst this smaller world. So the concept, let me see, here's the next thing. Yes, okay. So I'm gonna go ahead and just briefly show Mark's solution.
Like 1 minute.
Like 1 minute, yep. And just kind of give some indication of like how different it looks and maybe ways that, the desire to leverage what Mark's done, but also his implementation, and then how can we actually make it still more familiar? Because some of the ways that he put it together, for very good reasons, broke some of that familiarity of how things flow. And there we go, sweet. All right, modules. I'm gonna do C. I think this is it. Terrific. Okay, so in his program, you have to have these tags at the top of an event structure, right? So this still facilitates all of the tools, making a new event, having that event received by your module, and then do something else with it. But what he's done, he's actually put this event handling loop in a larger external loop that actually drives the program. Ignore this one for the moment. Let's just presume it's going to catch one event at a time for the sake of argument. And then the actual do of the program is over here in two different forms. Basically, instead of the TLB prime aspect of the brain being what state am I in, what do I do with my stimulus, Mark, in order to appease the DQMH gods, said, hey, I'm going to instead say what triggers have happened and then what state am I in and what do I do with that. He had it the other way before. I think it describes itself better personally in that other what state am I in, now what do I do? But, like I said, it ends up being a functional thing. So when there's no action to do, what trigger has happened, and then these are the states that now respond to that specific one. So it still has that concept of the brain in the system while still having, hey, here are all the actions available through the rest of the stuff. And I'll leave it at that for the moment. If you want to talk more offline, at lunch, whenever, Mark or me, that's fine. Okay. We're good.
This is your takeaways, homie.
Okay, yep, okay. All right, so. Omar Musa, who unfortunately isn't here, works at Virgin Galactic or Orbital right now. He did a presentation called You Might Be Wasting Your Time Debugging. Or Debugging is a Waste of Time. That was it. It was a catchy title, right? Debugging is a waste of time. Oh, yeah. But it's basically, if your programming paradigm naturally causes these common bugs, you're wasting time, right? You shouldn't be running into those bugs, especially if it's the same kind of bugs that you run into, like the happy dance problem or somebody did the wrong thing at the wrong time. Yep, if you're catching yourself dealing with your QMH code doing the wrong thing, yeah, there you go. It's like I wrote the slides here. And then recognizing that your program likely has different modes of operation is the first step to healing. And you can just say, hello, my name is Norm, and I have a problem with flow, right? And then explicitly this is a big one, explicitly declaring the mode of your program so that you can more smarter, do right things, be gooder.
Again, let me reiterate, this is Norm's slide.
Basically, once you start down this path, it's very likely that you'll have better choices that will flow out of that. And then all queued message handlers without state awareness and flow control are vulnerable to issues. It's not guaranteed, but depending on who you are and how you think, you're pretty vulnerable. And even Actor Framework is a queued message handler at the end of the day and suffers from these potential problems based on how you program and how you think about it. So in general, we need this for reals. So let's get it in.
All right, so just forget about everything Norm just said. If you write small modules, like I do, small, simple modules that can be individually tested, managing trigger response and state maintenance is less of a big deal. And most of that sort of module design comes for free with DQMH. Like it's going to encourage you to keep the tester for your module up to date so that you can continue testing that module. White space is totally overrated, although it looks like clearly I've added more white space between my bullet points on my slide, so maybe Norm's rubbing off on me a little bit. So if you end up coming up with an idea for some sort of conglomeration of theory to continue using DQMH, but with some other sort of mode of operation, like the prime design that Norm described and that Mark has implemented. It really only makes sense if you can maintain the integrity of the scripting tools of DQMH. Again, the creator of DQMH herself says the scripting tools are the most important thing. So if you lose those built-in productivity tools when you start hacking away at DQMH to make it, meld to your mind better, you're going to lose those productivity tools, and that's going to be a major hindrance. So yeah, all of these things that Norm talked about in his presentation, I have no doubt that he has run into those, and he has encountered code written by people and possibly himself that has run into these flow issues. I have been developing with DQMH for over 7 years. I have written some pretty complex applications with DQMH, and there have been very few times, it is not zero, there have been some, but it's been very few where I had to pay conscious attention and really dig into that management of trigger response and what to do. When that does happen, I tend to be pretty successful implementing helper loops in DQMH to solve those problems. The helper loop in my simple module was just doing some timing stuff. Norm was asking me about this last night. I have written some helper loops before that were basically kind of like a state machine as opposed to just doing some timeout type stuff. So it's possible, it's necessary sometimes. It's not necessarily nearly as often as Norm portrays it.
So this, and my counter take, this is Darren's definition of adequate white space. So we've seen, right? This 500 by 300. Oh, you gotta put your. But no, really, the counter takeaways, the big one is why settle for force fitting your flow control just to appease the DQMH gods when you can create a program that gracefully describes and enforces what you want to do. We know that it is possible. Luckily, Mark Balla, everybody who doesn't know him should get to meet him and know him. Indeed, has worked together to try to make this a reality. Jörg Hampel, over in Netherlands, I think?
He lives in Germany.
Germany now, okay. Indeed, has actually a published design online that actually merges this as well, where he actually registers for events in a certain state, and when you're out of the state, it deregisters for the events. So he's actually, instead of having two queues in an event system, he just has a queue in an event system. Very, very interesting. And then also DQMH Prime, which is this work in progress. And then Darren.
All right, I have a few counter takeaways to what Norm was saying. It should only take, oh, come on.